Hello everyone. This is my introduction blog for my Design for a Cause 2021 project. So, as you've probably seen from the earlier post, I'm going down the, I'll call it automated gardener aspect, and I've seen other ones do it, but I'm trying to take this a different route. I'm trying to make this as cheap as possible, as simple as possible, but also scalable. So you can go from just a 5-gallon bucket, which is where I'm going to start with, to grow, something like a tomato plant, all the way up to, maintaining an entire farm by just adding more and more and more. So I decided to sit down, and I started figuring out everything until I actually got the Arduino Nano 33 IoT that we're using in this competition here. So I'll show you some of the stuff that I've been working on here. So I'm sitting here at my workstation. I've got the Nano 33 pulled up on the internet so I can see the pinouts, and I started making notes. So first thing I did is just figure out what it is I need, inputs, outputs, and this I'm just throwing down all kinds of possibilities, what I needed to do, and then I started looking at the actual pinouts, labeling all the pins, figuring out where goes what, looking for reserved pins that I may be using and can't use for something. So you can see that I'm already going to lose 2 of the analog pins if I use I2C. So that's something to keep in mind. Then I started looking at which sensors I need to make this work. And so I started searching through a wholesale distributor here in the US, finding some, and I found a temperature sensor that looks pretty good. What I really like about it is it had a through-hole component or package, as well as a surface mount package. So I can easily get the through-hole component and experiment with it easily in a breadboard or some fashion. But when you look at making this a production scale thing, it has a surface mount version that could easily be transferred to PCB. Then I found a humidity sensor. I wasn't liking any of the choices that I found, but I found this one. It was fairly cheap at about $2, but it's I2C, and I really wasn't wanting to go I2C for the sensors, but it looks like it's going to be my only option because it was much more expensive to go for an analog or a digital one. Plus this one, if I remember correctly, so it's got the WDFN package. It's only surface mount. There were no through-hole components, which it makes prototyping a little bit easier. I'm going to end up having to dead bug that one. But it was very, very low power. Even in full read, it was still low power. So this is very beneficial to the project that we have going, because we're looking to make this as low power as possible, because it's going to look at implementation in remote areas. So then I need water level indicator, and I looked through a few things, but to start out with, I'm just going to use this water level or fluid level indicator that I found. The nice thing about it is it's made from polypropylene, and it's food safe material, so we don't have to worry about it poisoning our plants. But it's kind of expensive, $6 a piece. In the future, I will look at finding something that's a little more affordable, or making something. Then I started looking at physical connections on the board, how I was going to lay it out. So I started over here on the right with all the dedicated stuff. All my supply voltages, communication pins. I don't know if I'll use the RX-TX pins for UART communication, but I went ahead and pulled that out. I can always kick it back over and use for something else later. I do plan on using the I2C because of the humidity sensor, but that kind of opens it up for other stuff in the future, which is nice. Then I started looking at where I'm going to have to put, stuff like temperature and the water level sensor. Since both these are going to be a analog input, well, we'll use pins 4 and 5 for them, which is analog IO 0 and 1. So that's the start of this project so far. Not a whole lot in yet, but it's mainly just research until I actually get the board in hand. It can start testing and working on some programming. While I wait for the remainder of the time, I'll probably do some more research on some sensor stuff, and then also look at coming up with some pseudocode to get me started. That way I can hit the ground running. So stay tuned for the next installment, and hopefully we'll have more information and a better update when that comes around.